Okay, so in this video I'm going to talk about shock angle and the effect that it has on the jumping and cornering behavior of your car. Okay, and I'm going to confine this particular video to just straight arms. And in a later video I'd like to talk about gull-wing arms, but I actually need to study up a little bit more on gull-wing geometries before I can really make a video that I'm comfortable with. But in any case, for this particular video, I'm going to use my vintage RC10T for a few reasons. First being that it has flat, straight suspension arms, and the second being that there's a very important reason why you would want to use a particular shock angle in the rear, which I'll get to later. Okay, so let's start with the front here, where I have a particular initial shock angle with respect to the suspension arm. Now, if I'm applying a force to the shock will compress. And if that force is perfectly in line with the shock, then 100% of that force actually gets translated to the shock. Okay? Now, the way to assure that I have perfect efficiency in the force application to the shock is to make the shock perfectly vertical with respect to the suspension arm. That way all the force that gets applied to the arm translates perfectly into the shock. Okay? So that would mean that if I land off of a jump, if the shock is completely vertical with respect to the arm, as I land off the jump, all of the force gets applied to the shock, which translates to an effective shock stiffness that is smaller, an effectively softer shock. Okay? And if I start to lay the shock down, then only some fraction of the vertical force that's applied to the shock gets applied diagonally to the shock. Okay? So as I lay the shock down more and more and more, as I land off of a jump and the arm sees a vertical force load applied to it, less of that vertical force ends up getting translated into this more laid down shock. So what a laid down shock does is it effectively increases the stiffness of the shock. Okay? Now there is a difference in the effect of stand-up versus lay-down shocks on jumping and landing performance versus handling performance. So as the car is cornering and there's weight transfer from left to right, then what happens is instead of having a vertical force applied to the shock, you end up having a lateral force applied to the shock. You could say, in a very imaginary sense, it gets applied towards the top of the shock. Okay? And now if the shock is completely laid down and I'm pushing from the top of the shock out, the shock is laid down, then the lateral cornering load gets applied more efficiently through the shock. If the shock is completely stood up, then that lateral cornering load is less efficiently applied through the shock. So in terms of cornering behavior, if the shock is more laid down, then side to side, the suspension travel is going to be the suspension is going to be effectively softer. Okay? So as I lay the shock down, the suspension is effectively softer in terms of cornering load. And as I stand the shock up, the suspension gets effectively stiffer in terms of cornering load. So the effective shock angle on cornering behavior versus landing behavior is opposite. Okay? Now, basically, you could say that a lay-down shock makes the chassis roll more. Now, you can also make the chassis roll more by changing the roll center. Right? If I drop the roll center, that will also cause the chassis to roll more. But the difference here is that roll center does not affect the vertical compression of the shock. It only affects the lateral behavior of the car under a cornering load. Okay? If I change the shock angle, it changes both at the same time, the lateral behavior and the vertical behavior, as far as how lateral and vertical forces are applied through the suspension. Okay? So if you want your steering to be a little bit lazier, for example, then you could lay down the shocks and or reduce the roll center. But if you want the steering to be lazier and at the same time you want the front to be a little bit stiffer on landing jumps, you would lay down the shocks, because that would make the vertical landing performance effectively stiffer. It's like adding thicker oil or stiffer spring, but it also makes the lateral behavior effectively softer. Okay? Now, That's a very important concept to understand here for the RC10T and even the RC10 buggy, because these chassis are fairly heavy at the rear end. And especially on my RC10T, where you have longer suspension arms than on the buggy, and so the arm itself has much more leverage on the shock, because the shock is effectively further out from the axis of rotation at the inner hinge pin here. That means the shock will compress more effectively for a given landing force. So on the truck especially, the rear end tends to bottom out. And so my initial thinking at the time was, okay, if the truck is bottoming out, then what I could do is move the shock towards the inside hole to increase droop. And this will give me more suspension travel before the chassis bottoms out. And then what I could do is thicken up the shock oil, use smaller hole pistons, use stiffer springs to get just the right amount of suspension stiffness I need in the vertical direction to keep the rear end from bottoming out, and then I can just deal with the effect on handling. The problem is when you go to a more vertical shock angle, again, the handling behavior effectively becomes stiffer, and then you're combining that with stiffer springs, thicker oil, smaller piston holes, which give you more pack, and so the rear end can become very loose when you're actually negotiating a corner, even though the landing behavior might be improved. And what I noticed, interestingly, in this particular case here on the RC10T was all of those things combined didn't have as much of an effect as I wanted on keeping the rear end from bottoming out anyway. So what I ended up doing is going back to the standard setup for the rear shocks, which is to use a green spring, 30 weight oil, and number 2 pistons, which is a relatively soft or mild setup, and just laying down the shock more, so going from the inside hole to the middle hole. Now here, I put this side of the shock on the left side all the way towards the outside hole to exacerbate the effect, but what happens is when I go from the inside hole at the bottom to the outside hole, I get less droop. And so if you want to have more droop with a more laid down shock, you have to make the shock longer, okay? But this shock already has 0 down travel limiters in it. I can't make it any longer. So when you lay the shock down, you do end up reducing droop, which reduces the total suspension travel you have before the rear bottoms out. But the effect of laying down the shock on the vertical suspension behavior is enough to actually keep the rear end from bottoming out, despite the fact that you end up with less vertical droop. Okay, so this is a really important and interesting finding. Okay, so changing the droop on its own may not always help you with the vertical landing behavior. Okay, changing the shock angle may have a more profound impact. So that's something to keep in mind. So this is what I have on shock angle. The other thing actually that I wanted to point out with shock angle is, I think I already pointed it out, as the suspension compresses, okay, the actual angle between the shock and the suspension arm is also changing. So you can imagine, if we just look very closely at what the shock is doing as the suspension compresses, you see the shock actually starts to change in its angle. It starts to lay down a little bit, okay? But what's also happening is the suspension arm itself is moving up. So the net effect is that the angle between your shock and the suspension arm approaches 90 degrees as the suspension compresses. So if we think about what happens for, say, landing performance, as the suspension compresses more and more and more as it absorbs the force of a landing off of a jump, the suspension gets effectively a little bit softer progressively as the suspension compresses more and more. Okay? Now, what that would mean for cornering left to right is the opposite. So with this type of suspension geometry, as the chassis rolls more and more to the left or right, the suspension gets effectively, progressively a little bit stiffer because this shock angle relative to the arm is changing. Okay? Now, this is something that gull wing arms can address. If you don't want a progressive suspension behavior, you can use a gull wing arm to modulate that. So again, that's something I'd like to cover in a separate video, but you can kind of maybe imagine already, based on what I showed you here, how a gullwing arm might change that. Okay, so this is it for shock angle and the effect on jumping and landing performance, as well as cornering performance. And I hope this is clear to you. If not, please post questions in the comments section. And thanks for watching.